Okay, so what I'm hoping is here that we'll have some nice trickery in the way that the solutions are formed. So let's make a full set of tubes. Now, obviously I won't do this in the real thing, but I've got a master mix already made up. So let's create the rack. And I'm just going to put in 15 microliters of the BCA into here and 7 microliters into here, and then well, that'll do for the purposes of what we're doing here. So then I'm going to get some of this master mix and I'm going to put in 200 microliters into these wells. So 200, 200 and 200. And at the moment, the temperature of this is 22 degrees. And if we just start the clock going, we've probably been incubating for 10 seconds or so. Give it a mix. And let's check the absorbance. So 562, isn't it? 562 nanometers. And let's have a look to see how the absorbance is going. So it is these front three ones here. So yeah, there's maybe something happening there, but let's dilate time a little. See what happens if we take the time up a touch. So the second is about a minute. You can start to see some color developing now. Absorbance, yeah, a bit of linearity there. Oh yes, looking really nice. It's gone about 15 minutes and we're at 22 degrees and we're getting up to 0.86. And if we now go to about 30 degrees, 30 minutes when we're getting up to 1.05, so looking good. 30 minutes and absorbance, yeah, so 0.6, 1.2, looking nice. Okay, it's taken about 30 odd minutes to do that. Let's do that incubation again. So we'll take the time back down to nothing. These are still cooking, of course. I mean, there's nothing stopping them from cooking just because I've turned the speed down and just because I'm going to stop the stopwatch. But I will pipette 200 more microliters of this solution into row A. And this time we'll do it so that the temperature is a bit higher. So again, we'll put in 7 microliters. What did I do before? 7 and 15? I can't remember now. But 7 in there and 15 in there. Not exactly double, but close. All right, so give them a bit of a mix. And they're cooking. So, you know, they're brewing. They're possibly still doing something, but let's have a look at the absorbances. Yeah, it's not bad. That all looks all fine. Let's take the temperature up to 60 degrees. Now, it takes a little while for the temperature to get up because if you put them in the oven, the temperature doesn't go immediately to 60, so it's going to take a few seconds for it to go up. And what we'll do is keep an eye on the absorbance, but it's starting to increase a bit more than it was. And I reckon it's probably equilibrated by now. It's gone from 22 to 60. It sort of goes up a degree a second. So we're talking about 40 seconds or so for that to happen. Let's crank the time up a bit. And we can see that even if we're just going at 10 times normal now at 60 degrees, this is cooking a lot quicker. So in fact, even by 4 minutes, this is looking quite colourful. And you can see the absorbance there is double there than it is there, and it's already 0.7. We've been going for 6 minutes. The absorbance is now 0.9. We've been going for, well, let's leave this for about 10 minutes. But you can see that just the colours are really persuasive. And look, we're already 1.07, 0.57. But have you also noticed that we're getting a little bit of action here and a bit of action here? These are not complete blanks anymore. They've got a little bit of colour in them. They've got a little bit of colour. And if we increase now the time, so imagine that we're putting this in the oven for an hour. So let's crank this up. So it's now at 60 degrees. It's been in the oven for 20 minutes. The absorbances here are very, very similar between rows A and D. So those reactions have gone to completion, but the zeros are creeping up. So we're getting at this temperature and with this sort of time dilation, we're getting a degradation effect. Let's bump it up a little bit more, and you can really start to see this going now. So after an hour at 60 degrees C, we're getting quite a lot of color forming in the zeros. See, a 0.3, it's getting a bit mental. Now this solution here that's at 4 degrees, that's not doing anything. But the solution that's at 60 is. But if we now imagine that we crank this right up, so we've got 5 hours of ink, this has been in the oven now for 8 hours, everything's gone completely pink. But even the one at 4 degrees is really starting to go now. So about 20 hours after being in the water bath at 4 degrees C, this is getting a bit of colour to it. However, reagent A and reagent B are not. It's only when they're mixed together that this colour starts to form. So it's looking really nice. We're getting time-dependent colour degradation. We're getting it, and it's temperature-dependent. So the students are going to have to make precise timings, and they're going to have to monitor the temperature. I'm liking it.